This is R.D. Sharma solution, class 12th, chapter 11, differentiation. Exercise we are doing is 11.3. Differentiate tan inverse 4x by 1 minus 4x square. And this is the boundary, or you can say the limit or periphery we have to follow. Now, the first thing is we need inside tan inverse some result so that we get a tan, so that we can cancel it out. I'm writing the inside one, which is 4x. I'm writing it as 2 into 2x. 1 minus 4x square. 4x square is 2x square. If you take 2x as tan theta, the x will be tan, basically tan theta you need, so it will be theta will be tan inverse 2x. That we are going to use, but later on. Right now we are at tan theta equals 2x. Let us put it here. So 2 into 2x, we have tan theta divided by 1 minus 2x is tan theta, so tan square theta it will be. Now we already know by trigonometry 2 tan theta by 1 minus tan square theta is tan 2 theta. So we have got a tan here that we actually wanted. So it will be tan inverse tan 2 theta. Okay, 2 theta you can take it out because tan inverse you can cancel, but this is only possible for certain interval, which is minus pi by 2 to pi by 2. So let us go to the limitation which is being given, negative half to half, which is inside x. So we have minus 1 here, and this is 2x, and this is your 1. Okay, we have multiplied 2 everywhere. 2x is tan theta we have taken, so tan theta will be less than 1 and less than minus 1. So if you want to find out the theta for this, it will be pi by 4 and negative pi by 4, because we know tan pi by 4, tan 45 degree is always 1. It is 1. And tan minus pi by 4, because sine minus theta is minus sin theta, tan minus theta is minus tan theta. So we can write always minus pi by 4. Okay. Now this is your theta, and we need 2 theta, because when you cancel tan and tan inverse, you will get 2 theta. So you need to have 2 theta. So when you multiply 2 everywhere, what do you get? You get minus pi by 2, 2 theta, and this is between negative pi by 2 and pi by 2. This 2 theta is between this. So if we cancel this tan inverse, the range is negative pi by 2 to pi by 2, but it is actually equal to the cancellation. When you tan inverse cancelled, you will get minus pi by 2 and pi by 2. So this is the range, and this range we already have, and it is not inside, but it is actually equal to it. Now you can finally take the 2 theta. This is 2 theta. So what is theta here? Tan inverse 2x, first of all. It is tan inverse 2x, and since we have twice of theta, so it will be twice of tan inverse 2x. So basically you have to differentiate y equals twice of tan inverse 2x. Alright. So dy by dx, let us do 2. Tan inverse 2x is what? Tan inverse of something will be 1 by 1 plus this content square, 2x square in this case. And differentiation 2x by the chain rule, it will be 2. So 2 to the 4, 1 plus 2x whole square is 4x square. This is your final answer. Differentiate tan inverse 2 raise x plus 1 by 1 minus 4 raise x. And it is between, the x has to be between negative infinity to 0. And there are certain questions which are coming, which are like this only. And there is just one, when you take this boundary, there is just a simple trick which we'll use. So what we have to do, we have to turn this into something tan, so that we can cancel tan inverse and tan. So 2 raise x plus 1 divided by 1 minus 4 to the power x. This 2 raise x plus 1, we can write it as 2 raise x into 2 raise 1. 1 minus 4 raise x 2 to the power x whole square you can write always. Now let us take 2 to the power x as tan theta. When you take 2 to the power x as tan theta, what do you get? You get tan theta, 2 raise x is tan theta, and you have 2 also. So 2 tan theta and divided by 1 minus 2 raised x is tan theta whole square. Alright. Now we have just seen a question like this. 2 tan theta by 1 minus tan square theta is tan inverse tan 2 theta. This is tan 2 theta which we have just found. So let us write it here, tan 2 theta. So if you want to cancel, 2 theta has to be differentiated. Theta is simply when you find out tan inverse 2x, 2 raise x. But it is in the range or not, that we have to check. So negative infinity to 0, x is between this. Now let us take all the values to the power of 2. So 2 to the power minus infinity, 2 to the power x, and 2 to the power 0. 2 to the power of 0 is 1, 2x will be like that. And 2 to the power minus infinity, because it's something to the infinity, this 2x, 2 raised x is actually tan theta, because we have assumed tan theta to be 2 to the power x. So this is 2 to the power minus infinity is 1 by 2 to the power infinity. Anything to the infinity is infinity, and 1 divided by infinity is what? 0. 1 by infinity is 0. So this ultimately becomes 0. 2 to the power minus infinity, you can replace it by 0. So write it 0. Okay. So 0 and 1, no problem. And if you want to take the tan of, what is the value of tan so that you get 1, what is the value of tan so that you get 0. So it is simply, this is pi by 4, and 0 is of course 0. Tan 0 is 0. So your theta becomes the boundaried by 0 and pi by 4. Now you need 2 theta multiplied 2 everywhere. So 0, this is 2 theta, 2 pi by 4 is pi by 2. Now what is the range? When you cancel tan and tan inverse, it has to be between negative pi by 2 and pi by 2, and you are well inside that here, 0 to pi by 2. Now let us take the differentiation, y equals to 2 theta. So 2 into theta, what is theta here? Tan theta equals 2 to the power x, that you have assumed. So theta will be equal to tan inverse 2x. It is going to be tan inverse 2x. So this is 2, theta will be tan inverse 2 raise x. It is tan inverse, not square. I'll just change it. Ty by tx, so twice. Now tan inverse is simply 1 by 1 plus square of that thing which is inside tan. So 1 plus 2 to the power x to the power 2. So it will be 2 to the power 2x, which is essentially 4 to the power x actually. And what after that? Because we have to follow the chain rule. So 2 to the power x, differentiation of 2 to the power x will also be done. 2 to the power x. See, tan inverse x, differentiation is 1 by 1 plus x square. X square. So 2 to the power x to the square. So 2 to the power 2x, which is actually 4x. What is 2 to the power x? It is of the form a to the power x. And a to the power x differentiation is what? A to the power x log base EA, which is 2 here in this case. So what all we got? 2 to the power x and 2 you can combine. It will be 2 to the power x plus 1. And log base E2 will be there. 1 plus 4 to the power x. So this, the next question which is upcoming, most of the things will remain same. Alright. So this is the final answer of this question. Now differentiate tan inverse 2a raise x, 1 minus a raise 2x, a should be greater than 1, x should be between infinity and 0. So the solution I always show just for those people who just want to do it by themselves, and I actually solve because those who want to understand how this solution has come, what are the steps. So that is what we have to get a tan inside, because tan inverse is there. We need to get a tan so that we can cancel this tan and tan inverse. Okay, so 2 a to the power x by 1 minus a to the power 2x. A to the power 2x. So I'm writing it as a to the power x whole square. It's same thing. So a to the power 2x, I'm writing it as a to the power x 2 raised to the power 2. So we know that a to the power x, if you put tan theta, you will get the desired result. So a to the power x tan theta we have written. And in order to find the theta, you will get tan inverse a to the power x. And that will come just now, because we have to differentiate that only. So you replace it a raised x by tan theta. So 2 tan theta divided by 1 minus tan theta whole square, or tan square theta. And we have just seen in the previous two questions, it is tan 2 theta. So tan inverse, tan 2 theta, tan inverse cancel, 2 theta will be there. Y equals to 2 theta, you have to differentiate this 2 theta. Theta is already tan inverse a to the power x, so twice of tan inverse ax. You have to differentiate that. But you have to check that also. Negative infinity to 0, this x is lying between negative infinity and 0. So we have to differentiate that also. What is x? What is x here? Now let us take all to the power of a. All these elements which you see in the inequality, I am raising them to the power of a. So a raised minus infinity, a raised x, a raised 0. So a raised 0 is 1, 1, a raised x is x, a to the power minus infinity. As we have just seen in the previous question, which was 2 to the power minus infinity, it was 0. So you get a 0 here. A to the power minus infinity is 1 by a to the power infinity. Anything to the power infinity is infinity always. So 1 by infinity is going to be 0. And what is the tan angle of, what is the tan inverse of 1 and 0? It is pi by 4. And this is going to be theta, and this is going to be 0. So you have to be between minus pi by 2 and pi by 2 in order to cancel tan inverse. And since it is 2 theta, you have to multiply 2 theta also. So you get pi by 2 and 0. So you are well inside negative pi by 2 and pi by 2. Minus pi by 2 and pi by 2. Okay. So dy by dx, just do it, dy by dx. It is twice tan inverse a raised x, 1 by 1 plus a raised x whole square. This is the differentiation. A raised x differentiation is a raised x log a, which is a case, in this case, previous question it was 2. So this is the same question as the previous one basically. So 2 into a to the power x log base e is a by 1 plus a to the power 2x. Alright? Is this clear? Differentiate sine inverse under root 1 plus x plus under root 1 minus x by 2. So we need sine inside. We need a sine inside this. Please remember 1 plus cos 2 theta is always 2 cos square theta. 1 minus cos 2 theta is always 2 sine square theta. This we are going to use in this also and next few questions also. So 1 plus in place of x, replace it by cos 2 theta. 1 plus cos 2 theta. So, and 1 minus x, 1 minus cos 2 theta. So what you will get here is theta will be, see, cos inverse x is 2 theta. Theta will be cos inverse x by 2. So essentially you have to differentiate in the later part of this question cos inverse by 2. Now 1 plus cos 2 theta, 1 minus cos 2 theta inside the under root, and let us solve this first. 1 plus cos 2 theta, I just told you it is 2 cos square theta. 1 minus cos 2 theta is, I just told you it's 2 sin square theta. Under root 2 you can take common. Cos square theta will be cos theta. Under root cos square theta is cos theta. And under root sin square theta is sin theta. Just write sin theta. There is a 2 in the denominator also. So under root 2 you have taken, which is outside, 2 is already there. But we need a under root in the denominator also. So multiply numerator denominator by root 2 just to include this root 2 inside. So this above will become root 2 will be 2, 2 gets cancelled. So there will be under root 2 in the denominator. I am separating them with the 2 content. So we know that we are going to use certain formula, the trigonometric formula. So cos theta will be like that. Write just 1 by root 2. You can just write it as sin pi by 4. And sin pi by 4 is what? It's 1 by root 2. Here we have sin theta. Just write sin theta. 1 by root 2 you can take it as cos pi by 4. Cos pi by 4 is what? Cos pi by 4 is again 1 by root 2. Alright. So now this is a formula of sin a plus b. So you can just write it as sin theta plus pi by 4. And since this is the inside one, the outside one is sine inverse. So use sine inverse. Sine inverse sine theta plus pi by 4. So theta plus pi by 4, sine inverse gets cancelled. Theta plus pi by 4, cos inverse by 2 plus pi by 4 it will be, because theta plus 4, theta I already told you what is there. You have to differentiate this, y equals cos inverse x by 2 plus pi by 4. But let us see theta plus pi by 4, which we are cancelling sine and sine inverse, whether this theta plus pi by 4 corresponds to this periphery. Yes, cos 2 theta, because x is cos theta you have taken, it is between 0 and 1. Now take the cos inverse everywhere, cos inverse 1 and cos inverse 0. You know that cos 0 is 1, you know that cos pi by 2 is 0. So you have 2 theta between 0 and pi by 2. What is theta? Divide by 2 everywhere, you get 0, here you get theta, here you get pi by 4. Pi by 4. Now you need pi by 4 also, because you have to add pi by 4, because we are checking for theta plus pi by 4. The range is minus pi by 2 and pi by 2 if you want to cancel sine and sine inverse. So this theta you have to add pi by 4, and when you add pi by 4 it will be 0 and pi by 2. I have not added, I am just saying this will be between 0 and pi by 2. Now let us differentiate this cos inverse by 2, which is minus 1 by under root 1 minus x square by 2. Pi by 4 will be 0. Differentiate tan inverse under root 1 plus a square x square minus 1 by x. So whenever this type of question with under root comes, you have to eliminate the under root. For that, this you just see it is of the form a square plus x square. Okay, so whenever we have this form, we always put the content as tan theta. So what do we have? I am doing the inside one. Under root 1 plus a square x square minus 1 divided by ax. So put ax as tan theta. Okay, ax as tan theta. So what you'll get inside, 1 plus tan square theta minus 1 divided by ax will be tan theta. 1 plus tan square theta is what? Sec square theta. Sec square theta is 1 plus tan square theta. So it will be under root, this is actually under root sec square theta. So under root sec square theta will be sec theta only. So sec theta will come out. Sec theta minus 1 by tan theta, sec theta minus 1. Write it as 1 by cos minus 1 divided by sin by cos for tan. So this will become 1 minus cos theta divided by cos theta divided by sin by cos. Cos gets cancelled. 1 minus cos theta by sin theta. So 1 minus cos theta by sin theta. Again we can simplify it. 1 minus cos theta we have just seen. It is 2 sin square theta by 2. Sin theta is 2 sin theta by 2 cos theta by 2. You can cancel this 2 and 1 of the sin. So sin theta by 2 cos theta by 2 is tan theta by 2. So finally we got tan theta by 2 that we wanted, because outside it is tan inverse. So tan inverse tan theta by 2. Now you can just cancel it. Why? Because there is no boundary given. You can find out the direct answer. Theta by 2. What was theta? Remember, tan theta is ax. So theta will be tan inverse ax. Just write it here. 1 by 2 will be there. Theta will be tan inverse ax by 2. 2 is there. And tan inverse of anything will be 1 by 1 plus square of that thing. So dy by dx will be, this half will come outside, tan inverse ax will be 1 by 1 plus this ax whole square, a square x square. And dy by dx of ax will be, because of the chain rule, it is going to be 1. So you get a by 2, 1 plus a square x square. This is your final answer.